Welcome again to the second part of hypothesis testing. And in the first lecture, we tried to construct the relevant hypothesis test. And so we didn't work on problem 1 and 2 because those two questions are for your homework assignment. But we did problem 3 through problem 8. So today we are going to see how we test the hypothesis, how we test the null hypothesis to see if the null hypothesis can be rejected or if we won't have enough evidence to reject the null hypothesis. So you can see in the first lecture, we created the null hypothesis and also alternative hypothesis. And our intention is to reject the null hypothesis with the information obtained. And that information is the alternative interpretation of the existing information. But we can reject the null hypothesis if we can find a probability value that will be same as significance level or below or less. So the p-value should be less or equal to significance level, which always is provided. Or if it's not, then remember I mentioned in the first lecture that 95% confidence level is default, and therefore 0.05 is actually default. Some other times you may be given different significance level. However, any significance level, you need to get the probability value from the sample data, and that probability value should be less or equal to significance level for you to be able to reject the null hypothesis. If probability value is greater than 0.05 or if it's greater than the significance level, then you won't have enough evidence to reject the null hypothesis, and therefore you can say that you failed to reject the null hypothesis. We don't agree with the null hypothesis, but we failed to reject the null hypothesis. So how do we test this? Or how do we find the probability value that can either be less or equal to 0.05 to the significance level, or a probability value that is greater than the significance level? Or in other words, how can we get this probability value? We can get this probability value by using statistical techniques like z-test or t-test, and more like a chi-square test or f-ratio test. But in this case, we can only use the t-test or the z-test to find the probability value. And so I'm going to show you the easy way of doing this test. And the first thing for you to identify is this hypothesized average. And so we are hypothesizing the existing average, which is 50 degrees. And so let me write here, hypothesized average. And so in this case, our hypothesized average is 50. And then we are going to look at the alternative average. And if you look at problem number 3, you will see that there is this new mean temperature that was obtained during the last 40 years, and that is 51 degrees. That's the alternative average that was obtained from the sample data that was taken within the 40 years. And so we will call this alternative average is 51. Also, we need standard deviation, and we have two types of standard deviation. We have standard deviation of a sample data, and also we can have standard deviation of population, and sometimes this can be given. So if you have standard deviation of a sample data, then you're going to use t-test to find t-value and use that t-value to get the p-value or the probability value that will help us to test the null hypothesis. But if you are given standard deviation, or if you can find the standard deviation of a population, then we can use z-test. So here we have z, and also we have t. And we need to know the formula for z-test and also the formula for t-test to get the t-value or the z-value. So the formula for z-test in this case is the x bar, and x bar is actually the alternative hypothesis minus hypothesized average, which is this one in two brackets divided by the standard deviation of population, or the standard deviation which is given, divided by the square root of n. In fact, this is what we call the standard error. And so that will give us the z value. But we can also find the t value. Let me change this, the t-test, or the test that will give us the t value. And so it will be the x bar, or the average of a sample, and that is the alternative hypothesis, minus hypothesized average divided by the standard deviation of a sample, not of population, divided by the square root of the sample size. So those are the two formulas that we can use to calculate either z value or t value. So in our case, now we need to find out the standard deviation that we have. Is it of a sample or a population? So if you go to problem number 3, you will see that there is this standard deviation, and it states that the population standard deviation is 2 degrees. And so in this case, we have population standard deviation, which is 2. And we are going to use z-test instead of using t-test. And we are going to obtain z value. So to get the z value, we are going to apply the formula. And in this case, we'll put the equal sign, and we'll take the x bar, or the mean of a sample, or the alternative average, which is 51. And so I'm going to click on the 51 because already I have equal sign. And so I'll click on the alternative hypothesis minus the hypothesized average, and then divided by the standard deviation of a population divided by the square root of n. And in this case, we have 2, which is the standard deviation of a population, divided by the square root. If you type the sqrt, that will give us the square root of the sample size, or the size of the data which we use to get this alternative average. And you can see in problem number 3 that the study was done for 40 years. And that's why it says during the last 40 years, the average temperature is 51 degrees. And so here we are looking at the square root of 40. So close the bracket. But also we have to close the bracket because we have this one bracket here. And in this case, our z value is 3.16, and it is positive. So once you have z value, it's easier to get the p value, or probability value. And in this case, all you have to do is to apply function. And so put equal sign, just type norms. Please don't forget to put this s. In this case, you are given two choices, the norms dist and norms inverse. Since we have z value and we want to get the p value or probability value, then please use norms dist. And you have to put z value. And our z value is this one. So click on the z value, close the bracket, and enter. So here we have value, which is 0.999217299. That is not actually the probability value of the z, which is positive. So we will go back to the p-value function, double click. As I said, z value is positive. And when the z-value is positive, please type 1 minus this function, norms test. And if you enter, then you will get this probability value. So I'm going to copy this and bring it up here, but I'm going to paste it just as values. The p-value that was obtained is 0.00078. And remember, I said before that you can reject the null hypothesis if the probability value calculated will be less or equal to 0.05. And if the probability value is greater than 0.05, you will fail to reject the null hypothesis. So my question to you is, with this kind of probability, are we rejecting the null hypothesis or we fail to reject the null hypothesis? Think about it. So I'm sure you have suggested the answer. And so the answer here is we reject the null hypothesis because the probability value is less than 0.05, and therefore we reject the null hypothesis and accept the alternative interpretation, meaning that with the data that we found during the past 40 years, then we can see that the temperature has increased to 51 degrees, and that is significant. So that's all with problem number 3. So with this approach, you can actually work on the rest of these problems. But let's try to do a problem that will apply the t-test to see how t-test can also be used, or how t-value can also be used to get the p-value. So let's review this problem. The process for manufacturing of an alcoholic beverage was yielding 500 units, but when the system was modified, production went up to 535 units. And so the question is, do you think this increase is significant? So all we have to do is to do the test or the hypothesis test as we did here before, to say that the process is not different from 500. But the alternative hypothesis says the modification is greater than 500 and the value which was obtained, 535, is significant, and that can be proved by the probability value. And so all we need to do is to find the probability value that is equal to 0.05 or greater than, is equal or less than 0.05, which is significance level, to reject the null hypothesis and accept the new ideas that the modified process was actually significant. However, if we find the probability value to be greater than the significance level, which is 0.05, then we will fail to reject the null hypothesis. So how do we get this probability value? Now we look at the information which is provided, and we need to fill this simple model which we have developed. And so what is the hypothesized average for this problem? We can see it is 500. So let me write there 500. The alternative average, the average that was obtained after modifying the process. In this case, we can see it is 535 units. Then we need standard deviation, and that standard deviation can be of a sample, or it can be given, or it can be the standard deviation of a population. So let's look at this information. You can see that the standard deviation, which is 96 units, is actually given. It is not from this sample data that gave us 535 units. It says that normally the average yield for a process which is not modified is 500 and the standard deviation of 96 units. So that is actually the given standard deviation, or I will say the population standard deviation. And so in this case, it is 96 units. And I'm going to change here to put 96 standard deviation, which is that of a population. So when you change these values, you will see that z test, we get this value, which is 2.305, and p-value actually is obtained, and it is 0.01. Let me copy this p-value again, and let me paste it here, and I'm going to paste it just as values. So we need p-value which is less or equal to 0.05 for us to reject the null hypothesis and go with the new idea. But if the p-value is greater than 0.05, then we will fail to reject the null hypothesis. So my question to you is, can we reject the null hypothesis, or we fail to reject the null hypothesis with this p-value? Well, the answer is we will reject the null hypothesis because this probability value is less than 0.05, and so we rejected the null hypothesis. That is with problem number 4. Now let's go to problem number 5. So you can see that with problem number 5, we are given the average, or this is the existing information from Economic Research Department that states that the average salary of the family, or the family income on Metropolis, is this amount. And so we'll take this value, which is 48,432, and that is the existing information. And in this case, it is the hypothesized average. So I'm going to just change that value to this. Now the alternative average, it is the one that was obtained after doing a little research, where a random sample of 400 families gave the another kind of average, which is 48,574. And you can see this is this amount is more than the original amount, and the question is this significant, or it is just more or less the same as the original information? So we will take this information and test the null hypothesis, but we need standard deviation, and you can check here to see if we are given standard deviation or we are having standard deviation of a sample. So based on this information, you can see that a random sample of 400 families shows the average income of 48,574 with a standard deviation of 2,000. So that means this standard deviation is from this sample, not from the population, or it wasn't given. So in this case, we are going to use this standard deviation as the sample standard deviation. You could question about this sample size. It may look a little big sample size, and we know that when the sample size becomes bigger and bigger, then it approaches the population. So can we say this is a big sample size that we can consider to be the population data? Probably. But at this time, let's consider this as a sample data, because here we're talking about the random sample data. So this 400 is the standard deviation of the sample data. So let's write here 400. So in this case, we are going to use t-test instead of z-test to get t-value. And so I'm going to change this to be the t-test, but I'll change some functions here. In this case, our sample size is 400. So I'm going to add here 400. And then the h value, which is the standard deviation. In this case, we're going to use h H4, not H5. So I'm going to put H4 there so that we are going to focus on H4. That is the sample standard deviation, and everything remains the same. So if you enter, then the t-value is 7.1. And we need to change this probability value because for the t-test, you have to use the following function. If you have t-value, to get the p-value, please use the following function. You can put equal sign, type t-dist. So select the t-dist, and all you're going to do is to put the x value, which is the t value, and I'm going to click on this t value, and then you have to consider degrees of freedom, and degrees of freedom will be the sample size minus 1. So here we have 400 as our sample size, and so we'll take 400 minus 1, and so we are going to have degrees of freedom. You put comma sign, you can write 399, and then we have to consider the tails, and the tails in this case, you can see that the alternative hypothesis is focusing on greater than, and therefore that is one tail. And so I'm going to click one tail and close the bracket, and so you can enter, and that is our p-value. Here we have this exponential, meaning that we are going to have 0.12 zeros, and then you get this value. So it's very, very small, 0.12 zeros, and then 28767. So the p-value is 0.00. And so in this case, if the p-value is 0.00, so how can we explain this problem number 5? So the answer to problem number 5 is actually is that we reject the null hypothesis because this p-value is less than 0.05. So will you please use the same approach with the rest of the questions, and also you can work on problem 1 and 2. Just apply the same approach to see what you can get. Thank you.